All right, thumbs up from our wonderful staff here at NDC. Thanks a lot, everyone, for coming along to my session this afternoon. My name's Simon Waight, and hands up if you haven't been to an AI-based session yet at NDC. Oh, awesome, good. All right, I expected that a few of you might have gone to one already, but there are others to come after this one today as well. I'm going to take a look at, or posit the theory that perhaps you can become this mythical 10 times or 10x developer or engineer using generative AI. So let's get into it. New clicker as well. I had one of those things yesterday where I took my old one out, ready to practice, and someone had kept the receiver, which meant that it was of no use to me. So if I hit the wrong button, I apologise. So in today's session, we're going to take, first of all, a look at the 10x developer. Is it really a thing, or is it just an internet meme or a myth that we all like to joke with our friends at work about? How we got to generative AI. So it is an interesting journey to how we got to generative AI and GPTs, which has kind of been all the rage for the sort of last 18 months to 2 years. And then take a look at how that applies specifically to developers and what they do in their day job and the opportunities and risks that come along with that. Because like any new technology, yes, it brings some benefits, but there's also some things to be aware of. So I love the technology, but it is important to be pragmatic about the use cases for it and some of the pitfalls that there might be. And then it wouldn't be a tech talk without tempting the demo gods by doing a bit of a demo at the end. So I'm going to start with a blank canvas in VS Code and then see if I can build an app in whatever time I have left at the end of talking through the slides. And yeah, let's get into it. So 10x developer, let's start by, is it really just a meme? You may have seen this gentleman on Twitter, or as we call it now, X, riffing on the idea that the 10x developer is all of those things that we don't necessarily like about our colleagues sometimes. So it's the person who doesn't attend meetings, who comes to work late, wears the hoodie, seems to know all of the source code that's in the code base. And it's really just that, that hard to get on with intelligent person who, if they could just collaborate with everybody else, would be an amazing teammate. So that's kind of you may have seen some of this over the last few years. And I think this was about the time back in 2019 when this idea of the 10x developer really came to the fore, although it's been around for a while. I'm going to say I disagree with that, rightly so, because I don't think that's really a 10x developer. I think rather than AI, I want to call this an IA. And I'm pretty sure that unlike AI, which some of us may not have worked with yet, there's plenty of IAs that we may have worked with in the past or that maybe we're continuing to work with. So don't be one of those people. But 10x developer is not necessarily someone who is like that. So 10x developer actually does have some foundation in research. It's not just an idea that someone thought up. It comes from a piece of research in the 1960s that was done in the US that wanted to test out the fact that, to test the theory that there are some people who are more productive than others when it comes to building software. Rather than doing what some of us in this room might do, myself included, is take a group of experienced people and a group of less experienced people and then assign them the same task and then be surprised when the more experienced people seem to be more productive doing the work than the less experienced people. What this research project rightly did was it actually took a mix of people with an average of about 7 years of experience in building software. Now, the next thing that you could do, which I would probably do, is that you would give them a single programming language or environment to work in. And again, it might be that some of those people have worked with that language or environment previously and some of them haven't. Obviously, that's going to affect how productive that you can be in that environment. What they did for this piece of research is they used a synthetic exercise using a made-up language. So there was going to be a new concept to everybody involved in the piece of research. And actually, the research did conclude that there was a difference between people who are more productive and able to produce results much sooner than others in the team. And there was sort of the gap was 25 times for the production of the code, 10 times better execution for the applications. And it was really just, this idea that there are some people who work on software development teams who can be more productive. I think it's safe to say that we can all be productive. Hands up who's heard of the idea of flow or flow state. Yeah, so if you've heard of that, the idea that you are uninterrupted, having deep focused time and being able to deliver, against a piece of work that you've been asked to achieve, that's when you're really being ultra productive. And it's safe to say that I think for a lot of people, you can be a 10x developer in the right circumstances, but as this piece of research showed, you can actually have people who are just generally speaking more productive. If you do want to read more about that, unfortunately the piece of research itself isn't available to find online, but there's an excellent book which I've put the screenshot of the cover for there, if that's still your thing of reading hard covered books, called Making Software. And the chapter 30 in this book talks specifically about this topic and references this piece of research. So it's worth having a look at if it's an area that you are interested in. And the whole book is actually quite interesting about the process of building software out there. So 10x developer, it is really actually a thing. It's not just a meme that someone thought up for X or Twitter. So let's talk a little bit about how we got to the modern generative AI systems that we are using today or that we're interested in using today. I'm going to go all the way back to 1956. So there was a summer project at Dartmouth College in the United States, which ran for about 8 weeks in the mathematics department there. And it was actually focused purely on artificial intelligence. Now, as you might imagine, at that time in fairly recent history, a lot of the theory behind artificial intelligence was just that. We had only just really come over the cusp of modern computing, and we still had computers that were, houses of, content. You would have machines in, large data centers that would do a good job of processing things, but they really didn't have the capacity to do the sorts of processing that would be required to realise artificial intelligence capabilities that we have today. But this is kind of seen as the founding moment for modern artificial intelligence. It's not exactly when the idea originated entirely, but where we start our journey to get to GPT today, this is kind of that moment in time. I'm going to take a big jump now to 1997. That is a very big jump. A lot happened in the meantime, but as I referenced in that first point is the thing that didn't really change a whole lot, probably until the mid-80s, was the amount of compute power that we had available at a smaller scale and a large enough scale at parallel processing capabilities to allow us to recognise some of the benefits of being able to use machine learning at scale. So between sort of 56 and 97, right up probably until the early 80s, we were still working mostly with mini and mainframe type computers. We did have a small number of, supercomputers that were out there, but typically those supercomputers were not really targeted at doing the sorts of activities that you want to do with machine learning. It was more about running simulations and those sorts of things. But 1997 is the first time that we kind of start to see some real impact of AI on the world. So Gary Kasparov was beaten by IBM's Deep Blue. And it's an interesting moment, but I still think it's a little bit unrefined, because if you think about the game of chess, there's a lot of strategy involved in chess, but a fast enough and big enough machine that can understand how, say, Kasparov played his games can probably brute force what the next best move would be. So it is really still at that point of brute forcing on a very narrow point as well. This is just playing a game of chess. It's not a general AI. It's an AI or a machine that's designed just to solve one problem. And we've seen similar from IBM with Go as well recently, where they've had Go champions beaten by some of their machines. So that's one point. Then we take another big leap and we go to 2011, and this is really where we start to see deep learning and convolutional neural networks come to the foreground as well. So I went trying to find an image to represent this and failed badly. So what I thought I would do is I would fall back on everyone's assistant these days, and I went to Microsoft Designer and said, how do I represent a neural network as if it were in the stars? And that's one of the images that it produced. But the idea with deep learning and how it was novel to some of the approaches that have come before is you start to have these things called hidden layers, and you have multiple layers of hidden layers. So your input layer and your output layer are kind of the two bits that as users we would see. But then what happens inside of the neural network, the more of those hidden layers that you have inside of the neural network, obviously the more powerful it starts to become. So at this point we start to see CNNs come to the foreground, and we start to see the ability to have complex machines working unlike we've had before. 2017, So the researchers at Google Brain introduced this idea of transformers. So hopefully that word transformer might seem familiar to you, and not in the context of movies and manga from Japan. But Google did a lot of research to stand up Google Brain. You've probably heard of a tensor and used TensorFlow. They built this compute unit called a tensor processing unit, so that's an image of them there. But ultimately, transformers started to change the way we did machine learning at scale, because they allowed us to have models where we didn't necessarily have to have a large corpus of pre-trained data that was retrained on each go around the block. We could basically continue to have the machine improve on its own training capabilities through these things called transformers. So that's 2017. Now 2018, so it's only 1 year. And again, I went looking for an image. Interestingly, this is the best that the designer could come up with when I asked it to show a box with OpenAI flow, coming out of the air and people looking at it. I do love that all the people in this image appear to be wearing suits. There's not a lot of general public in that picture, but GPTs kind of go to the next level, where actually instead of having to do a lot of pre-organisation of our data, labelling of our data, we can actually start to use unstructured, unlabelled data as an input into training of these models. And because of the way that they're trained, we also end up with models that are not niche orientated. So what I mean by that is we had Kasparov was beat by Deep Blue. Deep Blue was a model that was trained to play chess, and that was pretty much all it did. Whereas when we start talking about GPTs, they generally tend to be good for a range of tasks without having to be necessarily trained to be good at those tasks. So I think there was a piece of research done independent of OpenAI that showed that even OpenAI themselves, when they released the GPT-3 model, didn't understand all of the capabilities that it had out of the box without having to be trained on how to do those certain things. And we can see that with what we're going to have a look at during the demo, where we're going to see a combination of Codex, which is a GPT-3 variant that's focused just on doing code generation, and also GPT-4, which drives Copilot chat from GitHub. So that's how we got to where we are today. So GPTs stand for Generative Pre-trained Transformers. So it's an interesting journey, and it's been a long one. And I think what we've seen over the last decade is obviously the growth of hypercloud, the absolute reduction in the cost of access to compute and storage. So we now have access to the capabilities for both storage and compute to be able to build these really massive models, in the billions of nodes. Still nowhere near as complex as the human brain, but well on the journey to doing that. Hands up who's heard of AGI? Who's worried about AGI? One person's worried about AGI. 2 people. Had to think about it a little bit. So artificial general intelligence is this idea that you will have, almost self-aware, self-managing systems that will be able to do anything and do it potentially better than a human. I think we're a little way away from that, to be honest, because the models are good and they can give you the appearance of being amazing. But if you scratch under the surface, you quickly determine that it's still got some limitations. So I know there are many people probably better placed than me that are talking about AGI as if it's, a 2 to 5 year problem. I don't know. I mean, I don't have visibility on that, but I don't think it's a 2 to 5 year problem. We may have systems that are very good in very unique spots in that time, but we're not going to have AGI taking over the world anytime soon. So let's talk about generative AI use cases for developers. And this is, the kind of summarization capabilities of these GPTs is actually a real strength. So you will see a lot of use cases, the Microsoft Copilot for Teams, something I use all the time. Can you ask it to summarize meeting notes for me, Teams chats, those sorts of things? That's a really strong use case for these models. So when we talk about developers, the idea that you can explain things and summarize things is a real strength. And that's, for me, really powerful when you start to look at code bases that maybe you're unfamiliar with or that you want to start to learn about. So you can open a code base off of GitHub or some other location and ask your GPT-based system to explain what the code is doing to you, and do it in a way that makes sense. So yes, you have to have a basic understanding of some aspects of what you're looking at, but the way that the descriptions are generated typically makes it easy for you as a human to understand. So natural language processing and representation is a real strength of these systems as well. The summarising complex code changes and broad changes submitted to software source control. So I put this deck together early last year off the back of a blog post that I wrote, and that was kind of the roadmap or the future of these sorts of things. The challenge you have with many GPT models is that if you've got a massive code base, trying to have the model analyse that, it's actually quite difficult given the limited number of tokens that these models can process in a single batch. But what we've seen since that time is you've now got GitHub Copilot Enterprise actually has this capability built in. So when you submit a pull request on GitHub Copilot, using GitHub Copilot Enterprise, it will actually augment your PR comment with a summarization of the changes that have happened as part of that PR. And it's not just a simple list of all the files that changed and the lines that changed in them. It's actually more of a human-centric description as well. So I think, for me, that's going to be where we start to see real benefit from these sorts of tools, is not as a replacement for us, but as an augmentation and an improvement as well. Hands up if you like writing really verbose PR messages or bug reports or any of those sorts of things. No one put their hand up. So it sounds like you're a perfect audience to start to pick up and work with this technology. The converting between implementations between different languages or different releases of the same language. So if you think about Python going from Python 2 to Python 3, potentially .NET going from .NET 4 to .NET Core and then .NET 8, as we've now got. There are some slight variances between those language runtimes, and doing the conversion, yes, you can do it manually, but why do it manually when you can have a tool do it for you? And a lot of these things as well, I see people go, oh, well, I've already got things that will help me do a lot of this today. I've got add-ons or extensions or third-party solutions that can do some of this for me. Not every programming language has that. So it could be you're working in a niche language that doesn't have that, maybe COBOL. It's maybe not that niche. Hands up if you're working on COBOL in this room. No one put their hands up, or they're too afraid to put their hands up. But if you think about core banking systems, it's a common problem, not just in Australia, but around the world, where you've got COBOL systems that are hard to maintain. They're still required to be alive. Having these sorts of tools available to you opens up the opportunity to have other people in a team who are maybe not experts in the language come in and do the majority of the work. You're probably still going to have an expert in the language QAing the work that they're doing, because I don't know what COBOL looks like, and the model might recommend something and it seems to run, but a COBOL expert might look at it and go, no. But I've now made it much more scalable to make those changes and have the person who is the expensive and rare resource doing valuable work, which is to just quickly once over the work that's being submitted, and probably actually looking at the future state and strategic direction of some of that as well. Generating documentation and unit tests. Hands up if you like to write documentation and unit tests. One person, two people, okay. Three people, okay, all right. Well, yeah, you might be out of a job thanks to this. No, look, yes, we've had unit test generators and documentation generators for a while, but certainly in my experience, the documentation generators, even if it's inline comments, do a really poor job of actually just explaining what the method is doing, unless you write the method name really verbosely, which most of us don't do. You have a method called do something, and then the comment generated by the commenting tool is this method does something. Awesome. With these tools, you now have the ability to actually have a human-readable description of actually what the method is doing by selecting it and saying, okay, document this for me. Same for unit tests. Yes, you've got unit test generation frameworks that you can use today. How about if you had an assistant that you could say, okay, I've got 30 unit tests for this class. Looking at the 30 unit tests and my class, tell me where the edge cases are that my unit tests don't currently cater for. And the system will do that for you. So talking to somebody last week, actually at the AI tour that was here in Sydney, that's a use case that they've come up with. So they first of all use Copilot to generate run-of-the-mill tests, and it will do like all of us, it'll generate all the happy path tests. And then they've iterated on it and said, okay, well, given those sets of tests and these sets of program files, give me some additional test cases that I might not have thought of. Now, they might not all be valid, but again, it's that sounding board of, pushing a little bit further and getting a little bit more out of, the work you're putting in here. And then this last one, I think this one is probably still a bit of a future use case, is looking across large code bases and finding opportunities for refactoring. And I'll talk a little bit about the inverse of that under the risks in a minute. But, I think where you were going to see this come to the fore is when we start to have much bigger context windows, token limits in these models, so we can start to ingest more information into what we send to the model to ask for summarization or recommendations for. And while we have patterns that allow us to do searching across documentation or code bases and add that as augmented information to our questions to the model, it's still not the whole of code base solution that we're currently looking for that would probably be required to do wholesale refactoring in many applications. Localized refactoring in a single method or a small number of methods, maybe in a library, for example, you can absolutely do that today, but whole of application, we're not quite there yet. So lots of opportunity. But there are some risks, and some of these you may have already read about or heard about, maybe some of them you haven't thought about yet. Data leaks. And this is probably early days, probably less so now. If you're using a commercially offered code assistant, Copilot, or one of the alternatives, there's a pretty good chance that you're not going to have data leak. However, if you're not using one of those, you may end up inadvertently leaking IP to some third party. I'll come back to that in a minute when we have a look at the examples. And these models are AI. They're not going to give you the same answer every time. They're non-deterministic. So I can ask Copilot, how do I write this C# file? And it will 9 times out of 10 give me the same result, more or less. And then the 10th time it might give me something completely random that doesn't make sense or doesn't work because it's a big probability machine behind the covers. It doesn't really actually understand what it's producing other than it knows that you asked for a C# bit of C# code that solves a problem, and it's using the corpus of knowledge that it has to put together the next best guess and return the result to you. So it is important to understand that, yes, you can accept the responses you get from these systems, but it's also worth considering, is it actually solving the problem that you've asked it to solve? And that means that you have to read through what it's presenting to you and not just right-click accept yes. It could be incomplete. So it could be that you've asked the back-end model to solve such a big problem that it might only give you part of the solution. The way you deal with that is you break the problem down into smaller chunks and you ask more pointed questions of the model so that you can actually get to the result that you want through a series of steps and refinements. And then insecure responses as well. So as you might imagine, models that are trained on very large data sets of publicly available data will include a range of quality data in those inputs that they've used for training the model. And that will absolutely include insecure code. So something to be aware of. And again, this is becoming less of an issue. But if you have no controls in your software development lifecycle today in your business for doing things like security scanning or being able to look at the validity of packages that you're pulling in from places like NPM, all this is going to do is going to turbocharge those issues and bring them right to the fore. You're not going to have, different issues here. You're probably just going to have them more rapidly because people are going to be more productive in working with the solutions. So let's have a look at a few of these. The first one, you may have all seen this one. So this was Samsung. Kind of when the first hype of ChatGPT came out, the guys and girls at Samsung thought, hey, let's look at seeing if we can use ChatGPT to improve the performance of some internal tooling that they use. Excuse me. So they took their company IP and they went to the public version of ChatGPT, so the one that we've probably all tried, and they pasted it into the chat window and asked for recommendations on how to improve it. Now, if you read the small print on the free public version of ChatGPT, it clearly says that they will retain whatever you submit as part of that prompt for training. Now, if you use the business version or one of the other solutions from the likes of Microsoft or Amazon or Google, you'll have the option to control what happens with that data. So the thing to be aware there is the context, but also you need to be aware of who you're signing up for and what you're using. and maybe what your teams are using as well. Common problem I see is that there's the blanket ban on using these tools because we don't understand it or we don't have the licensing in place. I can guarantee you that people are using these tools through other channels. So it's better to figure out how you can enable people to use these systems securely with the right protections in place than it is to just outright say, we're not going to use it. I don't think that happens very much anymore. I think the rate of change in this space in the last 2 years has seen a lot of thinking around adoption of this sort of technology, and new technologies change quite a bit. So people are absolutely doing trials, pilots, and then figuring out how they can enable their organisations. So I'm doing a lot of co-pilot work at the moment. The AI package hallucination, I hate the word hallucination. Who knows what hallucination means?
Simon Waight was saying it. It's where it speaks with the confidence of a mediocre white man.
Thank you. So the summary, which is probably I'll use the more friendly version of that. So yeah, it's that it produces an inaccuracy or an error, and I think by calling it hallucination, we project a personality onto a machine. So let's just say that it's an error. And this is actually a webinar. I don't think we've seen this attack vector just yet, but it is an interesting one to put in the back of your mind. So what they were saying is, hands up if you're a Node.js developer or a JavaScript developer. A few people. Okay, so look, all modern languages have package managers that allow you to import libraries that will allow you to more rapidly develop software solutions because you can benefit from all of the work that goes into building those libraries. What these folks were saying, and it was a webinar, so they're obviously trying to sell you on their supply chain security solution, was that these systems, so the GPTs of the world, will quite happily spit out, say, a piece of Node.js code that will have a series of import statements at the top. Those import statements may actually point to non-existent packages because it's just making text up. 9 times out of 10, again, it will probably still be a valid package, but every 10th time it might point to some non-existent package. Now, because they're fairly repetitive and it's easy to hit APIs and ask the same sorts of questions, what they were suggesting is that attackers would, over time, be able to generate nefarious packages and place them into the NPMs and the NuGets of the world. And then developers would blindly accept the suggestions from the model, which would include the nefarious package references, and because the nefarious package reference actually resolved because it existed, they would download it and run it, and you would be none the wiser that you just ingested a nefarious package. I think that one's a little way off. It requires a lot of work to get to the point of being able to extract data from it. But I do think supply chain protection for third-party packages is going to play a big part in reducing the risks involved with that. Again, if you're just blindly accepting the suggestions, then you've probably got problems to start off with, right? You probably want to be doing some inspection. So if you've never seen a package before, it's not part of your ecosystem today, you probably want to be looking at what it's doing before you accept it into the code that you're building. One on the top there, coding on Copilot, this actually just came out quite recently. It's a bit of a clickbaity headline and story. So it's actually a bit of a puff piece for Git Clear, who will help do analytics for your Git environments and figure out what's going on inside your repositories. They showed that in those organizations that were using, and this was specifically GitHub Copilot, that there was a massive amount of code churn in those parts of the code base where Copilot was being used to make changes. And oftentimes code that had been submitted into the repository was oftentimes reversed back out a couple of weeks later. Look, in fast-moving environments, there'll probably be a lot of code churn in your code base anyway. I think, there's kind of a balance to be had there, because actually if you're moving at a fast click and you are accepting point results from, say, Copilot, and you're committing that code, maybe it's being pushed to production and it's running in production, there's a pretty good chance it'll probably get refactored at some point down the track. Now, is it the fact that it's maybe a 2-week time frame rather than a 2-month time frame? Look, I think, again, it comes back to the process that you have. So if your process today isn't making good control of that process, the way that you do that, adding Copilot in is just going to turbocharge the problems that you have. So coming back to the fundamentals, It's just a tool. Make sure you've got the right processes and approaches in place. The one who answers it better, which had a look at ChatGPT and Stack Overflow. It's a bit old, but look, they said that the ChatGPT was only accurate 52% of the time, and the answers tended to be quite verbose. And I think we've probably all used ChatGPT and see it write an essay when you just wanted effectively a 2-sentence answer. Look, I think part of what we're focusing on with these new generation of tools, particularly for developers, is reducing context switching and bringing people out of the work that they're doing. And I have to say that a big change for me is to break that muscle memory of I hit an error or I don't know what to do. I'll tab out into a browser and do a search. With this tooling embedded in the IDE, I need to stop doing that. And the first thing I need to do is I need to use the tool I have right in the context that I'm working in with the context of what I'm doing, rather than having to copy and paste code, which, hey, we've probably all, why doesn't this work? Copy and paste and run it. So maybe we're back to the first situation with Samsung there and leaking IP. But the reality is that actually, I think maybe ChatGPT is a bad example here because we're talking more about the Copilots and Amazon Code Whisperers of the world that you can embed in your IDEs. But for me, it's that lack of having to change context that is the big benefit. And then the last one, this came out quite early after Copilot was shipped by GitHub. And in the early days of Copilot, it was definitely an issue where what would happen is that you would get, say, a SQL injection attack recommendation back from Copilot. So you would say, give me a piece of code for C# that inserts data into a SQL database. And occasionally it would give you something that was basically prone to SQL injection because it wasn't doing the right sorts of protections. In the meantime, GitHub's worked hard on improving their filtering on their API so that the chances of you getting insecure recommendations back from the GitHub Copilot service are pretty low. And in fact, if you look at Copilot Chat, it will now give you a visual representation in chat where it thinks that there is something insecure in the code that's in the context window that it's working on. So as part of the demo, I'm using a service that's got a key in it, and you should be able to see as part of the demo that it shows that, hey, you shouldn't be using this service key in your code because I'm a bad developer and Copilot's trying to stop me from being insecure. So definitely things to be aware of. These are probably less focused, but no less important. If you're using a tool to do a percentage of the work, over time will you start to lose organisational know-how on how things are built? Yes, it's absolutely a risk. How do you cope with that? Well, by making sure that you've got regular overviews and architecture sessions of how the application is built. If you're doing code reviews as part of your product or software development lifecycle, that's a good way to learn about things as well. But definitely there's a challenge where if you're starting to just accept recommendations from a tool all the time, you might start to forget how things work because you're not having to dig into the code to look through that anymore. Bloated code bases. If you can right-click and generate all the tests for a particular class, should you really be doing that? I'm sure the testers, if there are any testers in the room, or the kind of the people who are really keen on that would go, absolutely, you should have test coverage across 100% of your code base. I would argue you probably don't need that. In the same way that if you're building out an API or an API client, you don't need to consume every single API that's represented by the remote API. You might only need 1 or 2 calls, but if the tool will generate all 15 endpoints for you, you might be tempted to just go, sure, why not? So there's definitely a risk there that you might end up with more code either directly in your application or in your unit tests. So again, making sure you're keeping that top of mind is worth thinking about. Missing out on novel solutions, and what I mean by that. So who knows what the Carmack constant is? Or the Carmack magic constant. I don't know if that's exactly the right word. So one person knows what it is. So I'll see if we're talking about the same thing. So who knows Doom? There we are. Okay, and so when Doom came out, one of the big challenges was the compute power that was available to PCs at that time and the 3D graphics engines that were under development effectively by John Carmack and the team at id Software. And as part of the work he was doing to try and speed up, I think it was the shader for their 3D engine, he came across this magic constant that he could insert into the code and create a massive increase in the performance of their 3D renderer. And I forget the reason that he ended up at that point, but I think if we were using these sorts of systems that we would miss out on those sorts of novel approaches because these models are not designed to work like that. They are a probability of the machine that's looking at what's the next best token to present to you. They're not looking at actually what's the problem we're trying to solve here. So there is a risk that you won't have those novel solutions in your environment anymore if you just start to use these GPT-based systems. RAG, so that augmentation generation, that's kind of a pattern that's come to the fore where you can use your organisational knowledge to augment the model's capabilities and get additional insights back. So when you use GitHub Copilot Chat, you're using a very lightweight form of RAG because you send context with your request. I'm not sure about you, but I've written a lot of really bad code in my life. I'm not sure I want GPTs to be using that as their reference point. I think where it makes sense is if you've got maybe organisational standards or best practices that you would use it in that case. But I think, do you want it to ingest and be able to produce outputs based on all of the code in your organisation? Probably not. So thinking about how you want to do that. And the last one, job security. Hopefully at this point in the talk, you're not worried about your job because it's pretty clear that there's still a pretty big role for us to all play in the industry. And then the final point is, famous quote out of Jurassic Park, you were too busy, you were so preoccupied whether or not you could, you didn't stop to think if you should. So that, for me, is just because the tool does it, do you really want to use it just to do that? All right, demo. Enough slides. Let's see how we go with this piece of this afternoon. So I am going to use everyone's favourite free editor, GitHub Copilot. It's a clean slate. I have nothing open at the moment. I've got a command prompt here or a Linux prompt. And what I'm going to do is I'm going to use Copilot to basically go from nothing to a working application, he says. How are we doing for time? How much time have I got left? Not much. So we'll see how we go until the doors open and we get thrown out. So there are, with the new versions of Copilot Chat, there's these things called agents. So there are 3 of them. Let's just zoom in on that. So you have @terminal, @VS Code, and @workspace, and they can be used to drive automations or interactions with that context. So actually what I'm going to do is, for this I think I might use Python. So what I'm going to do is I'm going to say, how do I install Python? Because maybe I don't have Python on this machine. If I can spell machine. This is where we test out the internet connectivity. So it's here because it's looking at the terminal. It can see that I've got, in this case, an Ubuntu-based terminal in the background. And it said, okay, well, this is what you need to do. And then what I'm going to do, you can see that there actually that text is actually superfluous. It doesn't actually relate to the instruction that's given. But what I can do is I can actually tap that, insert it into my terminal. And at this point, I'm going to fat finger that. This shouldn't be too long because I've actually already got all the right bits. I did that yesterday just in case Wi-Fi wasn't working today. He says, so while that's running in the background, what I'm going to do is I'm going to use Workspace. So Workspace is about the project that I'm working on. And what I'm going to do is I'm going to ask it so I can ask it to explain, fix, or create a notebook, which is what's the word I'm looking for? For doing data analysis. Jupyter Notebook, thank you. So you can create a new notebook and then test. So actually what I'm going to do is I want to do new, and then it's already recommended that I can actually ask it to do scaffold code for a new workspace, but that's not useful because it will probably ask me a series of prompts. So what I'm going to do is I'm actually going to copy this and paste this in. So this is quite verbose. And that's a key learning point when you drive these models is the more verbose and pointed you can be in the instructions you give it, the better the response will be that you get out of the system. Now, I obviously have to have a little bit of knowledge about what I'm doing to do this. So research from GitHub says that experienced and intermediate level developers will be the most proficient using Copilot. People who are less experienced will struggle a bit because they don't necessarily know what they need to ask the Copilot to do for them. But we can see I'm going to create a web app. It's got one page where I can upload a JPEG, and it's going to use Python on the API and call a bunch of stuff. And I'm giving it a very specific version of the API because I want the right libraries to be suggested to me. So let's go ahead and run that and see what happens. So you'll see there that Copilot hasn't actually created it. What it's done is it's recommended a layout. If we just zoom back out on that. There we are. So that's a proposed directory structure. But what I can actually do is before I actually go ahead and commit this to disk, I can actually look at what it's doing here. So let's just decrease that. So it's generated a placeholder. It's even given a good page title and all those sorts of things. It's got some JavaScript there to do the upload. It's created a Python app for me. Has it got a requirements.txt? It's got a requirements.txt file as well, which is about defining what Python packages I want to pull in, or Python libraries. So that's pretty good. So what we can do is we can actually, there's a button under this that says create workspace. Boom. So I'm just going to go ahead and create workspace. Let's create do it there. So what it's doing is it's going to stream those results down onto disk, and what will happen once it's done that, it'll actually open it in a new workspace inside of Visual Studio Code, so I've just got that context available to me. So these files are being generated in real time by Copilot's backend. It's being a bit slow today, probably because everybody's using it at this conference. All right, so reload the context. You see it's gotten my web app. So when that loads, it should have the source. Now, the interesting thing is if you look at the README, it's done a reasonable job of capturing the requirements. So I haven't done anything. So it's literally written, the README for this without me having to do it. So I can literally just go through and edit the contents of this, and I'm already ahead because I haven't had to write any of that or create the structure. So let's close that. Who wants to take a bet whether or not this is going to run the first time? All right, so let's grab that. Oh, come on. Oop. Let's grab the terminal. So I'm going to see if this will run. Yesterday I couldn't get it to run because I don't have the right configuration for Python on this machine. Okay, let's go Markdown open. That won't work. Thanks for that, Visual Studio Code. So what we might do is cd source, and then we'll do Python .py. Okay, all right. All right, so it's already given me an error there. So what I can do is I can actually hit here, and I can ask it to explain what's going on there. And then it gives me some suggested things that I can do. So I'm pretty sure that what that means is that I probably need to actually restore the packages. So if I do, where am I? Here, and then my requirements.txt is there. So let's just have a look. Okay. All right, so there's the question I can ask Copilot rather than going and looking at the internet. So how do I install? Let's zoom in on that. Python packages from requirements.txt. So I've done a bit of Python, but I'm by no means a Python expert. All right, so there we are. So what I can do is I can actually bump that into my terminal. All right, so it's downloading those for me. And then let's go back into source and we'll try Python 3 app.py. All right, cannot import the name escape from, all right, so let's go and have a look at what's going on there. So let's open up our file and we'll just minimize this. So where is it complaining about? It's complaining from Ginger. So Flask init in modules, so suggests to me that there's still stuff missing out of the install. So what we might do is, I'm going to delete that. I actually think the requirements.txt file that it has is wrong for this. All right, so it's already installed. All right, so that's complaining about that, so it's unknown. So let's do this, and we're going to ask Copilot. So I can also ask, if I'm not happy with that, I can ask it to regenerate. So I don't have to just go with the first response that it gives me. It's not actually answering the question. I've asked it here because I've not asked the right question. So I would probably want to ask it, all right, and that's probably the wrong context because it's trying to do an inline fix. So let's copy that. We're going to go over and chuck it into chat, which is our kind of broader thing. So you'll see here it's actually using my file for the reference. So if I zoom in on this and I can open it, I can see what it actually sent as part of that call. So when you work with certainly Copilot, and I'm guessing the other solutions that are out there, the context of what you have open in your IDE matters. So for Workspace, you can start to work with more files, but because I have the app.py file open, it can go and have a look at the context that I'm asking it about and make some recommendations. So let's go ahead and install that. All right, and then let's try run it again. All right, so that's still failing. So let's just have a look at this. I'm going to whack that. So you can see rather than going and doing a Google search or a Bing search, I'm just using Copilot Chat to do that for me. So it's saying I need to install Ginger. That's okay. So let's do a pip install Ginger 2. All right, so it says that it's already installed. Awesome. And then let's just go back and we'll do, let's just see if that's going to run now. All right, so it might be because I'm in the wrong place. Let's try. No. All right. Yes. All right, let's see how we go. So Michelle is recommending we do that, and we do fix. See what it says. So it's recommended a whole, I don't know if it's made any changes to the code that I've got in that file. But at this point, I'm like, the code is correct. Issues with the spell checker not recognizing. Yeah, okay, so it's just the spell checker. I've got a spell checking extension installed here, so that's fine. So that's not actually going to solve my issue, but that's cool. Nothing like live coding an application. So I'm going to try run and debug from here, which is the Python debugger. We're going to debug Python file, see how we go. I suspect it's more just my context. Okay, there we are. So so an import error has occurred. That's cool. Oop, come on, let me select that. So I suspect that might be an error with escape not actually being a thing in Ginger 2, or at least the release that we've got. So this is where you run into these sorts of challenges, because sometimes the code that's being used to train these models refers to deprecated APIs in the solution in the particular library. So let's have a look. Yep, so it is installed. All right, so we could try upgrade. It should be the most up to date because that's what we've already got installed. We'll try that. All right, so that's already installed. Python might be corrupt. All right, so have I got a Python virtual environment running? I haven't. So how do I? So I'm going to ask it, how do I create a new Python environment? Because it says here the last one is your Python environment might be corrupted. So let's go ahead and create a new Python environment. So the interesting thing with code spaces is the inline autocomplete for Copilot doesn't work that well. So Copilot chat is fine, but the actual inline completion doesn't work. So let's go ahead and create a new virtual environment because that's what it's saying we should do. Yep, so let's change to that virtual environment. So obviously some of the demo I'm doing here, I know a bit about Python, so I know how to debug some of these things. But in the real world, you would potentially be giving existing code bases and solutions to people to work with. So they're not necessarily having to do grassroots development or have a deep understanding of a particular framework that they're working in. So I know about virtual environments. I can see now that I'm in that virtual environment down here. It's got it highlighted, so that's fine. And then I shouldn't need to activate it because it's already activated here. So let's go ahead and stop the debugger. And we'll try the debugger again. Okay, no module name Flask. All right, I need to install everything because I'm in a new environment. So let's do pip install Flask. And we'll try again. Okay, I don't want to install that. Oop. All right, no module name Flask. It still doesn't like that. Okay, interesting. So I had problems with the Python debugger yesterday, so let me just try and run this from the command line now that we're here. Okay. Okay, import Flask. All right, so it looks like that's wrong. Let's have a look, see what Copilot's got to say about that. Yep, so I've already done that. So I'm running around in circles here. Awesome. So packages, Python 3.8. All right. So let's see what Copilot says on this one. Okay. All right. So I could do here's one I did earlier, but I don't want to do that because I want to show you how you can use the tool to help drive through these sorts of situations. So for me, it's probably a problem with my Python environment on this machine, which is not the best. So it should be importing that. So Flask is there. Let's do pip install Flask again. Okay, so it's already satisfied. It says that it's there. Interesting. And let's see whether we've got that other library installed. Where are we?
One of the previous Copilot suggestions was to drop that.
Yep. That's all right. Thank you. Whoever that was, the Copilot recommendation from the back there. So that file's actually not in. That's not installed at the moment because basically I haven't added it into this new virtual environment. So I need to install it. So because I've forgotten, because I have a memory of a chimp. Let's see, how do we install? All right. All right, so it says that it's installed. I wonder if what we need to do is, where are we? Give me a new terminal. Oops. So I'm just going to close some of these terminals here. And get a new one, and let's get a new terminal. Okay, that's good. So you'll see at the front there, so I think what was missing is you see how it's got my-env on the front there. I didn't have the right environment running. So if I go to src, Python 3 app.py. Okay, so pip install Flask because I wasn't in the environment. So this should install stuff. Good. Pip install. All right, so. All right, API vision. All right, so that's wrong. So that there is an invalid bit of code. So I actually need to fix that so I can actually ask the system, how do I fix that? No, so that's not helping. Come on. So basically, when it's generated that Python code, the .api.vision is actually the wrong library to refer to. So it needs to be corrected to point to the right one. So it's probably not going to tell me how to do that in this one. Just zoom in on that. Okay, so that's probably my missing piece. So if we zoom out on that, and I'm going to pip install that library because it's missing. And then what I can do is I'll keep that old line for the time being. And what we'll do is here and pop this in here. And we'll delete that. So it's complaining about all of those right now. Let's see how we go when we run this. Okay. Having a good day with my app. It's one of those things where you do the demo yourself and everything runs as expected. And then when you do it in front of a live audience, it doesn't. All right. So we've got a few minutes left. Look, that's me driving it badly in a language that I don't understand. I would suggest let's have a quick look at, and then we'll wrap up. So I am going to do the quick here's one I created earlier to prove that it's user error and not system error driving this. So we should be able to. And this is exactly the same prompt that generated this code. So we should be able to go into source here, then do Python 3. Okay, Python 3. Stop taking focus. Come on. User error. All right. So this is actually the application I did want to show you. It's a really great one. Choose a file, you can upload it. Okay, so there's an error in there. That's just because I didn't finish building out the application. But what we've got here is a functional Python application where I've gone from nothing using the workspace create new, and then using Copilot to help debug the issues. A bit easier when you don't have a group full of people in a room looking at you talk. But yeah, I actually had this working quite successfully yesterday. So there is, I think value in using these tools because it will allow you to open up the opportunity for people on your teams to do more work in maybe languages that they're either interested in learning or that you would like them to maintain that they maybe don't today. Before we wrap up, I'm happy to chuck this up on my blog as well. If you want any of the content out of today, please just hit me up on LinkedIn. You can get me there, so Simon Waight. And yeah, that's a series of links. So we looked at Copilot today from GitHub, but there are a few others out there. Interestingly for me, Google's kind of a bit all over the place, or has been a bit all over the place in terms of what they're calling their tooling. I think they seem to have landed on one name or two names. So it's been quite hard to kind of nail down exactly what is like the Copilot equivalent from the Google ecosystem. So they have something for working with Google Cloud, but it doesn't seem to be like Copilot where you can run it inside of Visual Studio Code and work effectively locally. It's really just designed to help with their environments. Code Whisperer, I've heard mixed things on that, but if you're in the Amazon ecosystem, it could be a good thing to look at. Codium, they did a comparison of the tools. They, unsurprisingly, build their own, so obviously theirs is the best, but it is a good overview of the options that you have out there. Replit Ghostwriter and Tab 9, and I believe that the JetBrains team is also bringing an AI-based assistant as well, albeit you can use Copilot with the JetBrains range of IDEs. So that's pretty much it. Hopefully today, despite my fat fingering of the keyboard during the demo, you've come to realise that these pieces of technology can actually help you become, and your teams to become, more productive in building software. And I think, I would agree with the statement that generative AI can help you become a 10x developer. Thanks a lot, everybody. Appreciate your time. They do say that you shouldn't do demos with children, animals, and generative AI. And I've just proved that.